Our eyes help us to see the world, but you can't see this dot if you close your left eye, stare at this cross here with your right eye, and slowly move your head towards or away from the screen. The dot will disappear, revealing the exact location of your blind spot. The cells of the back of your eye transforms light into signals that are sent to your brain, but they are missing right here, because this is where nerves and blood vessels connect to the eye, so at that point of vision you can't see anything. It is also known as your blind spot. If we add a line through the image and you try again, you will notice that your brain fills in information, and makes you think the line is continuous instead of there being a hole in your vision. You also can't see all 12 of these black dots at once for a similar reason. The exact point your eye looks at is focused, but your peripheral vision isn't great, and so your brain often makes assumptions for what's there. Because of the consistent gray line pattern, your brain assumes the rest of the image is just like that, and misses the black dots until you look directly at them. These two rectangles are flashing out of phase with each other, right? How about now? For most, the rectangles will now seem to be flashing at the same time in phase, but they aren't at all. And yet if we move these shapes beside them, just a few pixels, you will begin to see them out of phase again. The surrounding area has a direct impact on how you see and perceive things, even if the result isn't correct. Now look at this flashing squares. Except what you might have seen is that the middle square isn't flashing at all. If we remove the outer square, we see it for what it is, a solid color. Now try reading the sentence inside it. Did you catch the extra words? Our brain doesn't always notice extra mistakes like these because it doesn't affect the comprehension of the sentence. And your brain would prefer to act quickly rather than be perfectly accurate. Try staring at the middle dot in disillusion. When the picture isn't moving, the colors are clearly changing quickly, but when the image starts rotating, the color change either seems non-existent or much slower. Our eyes and brain have evolved to see, but our vision makes assumptions based on learning, memory and acceptation, and all of these illusions take advantages of adaptation. If you stare at the center dot long enough, the brain will simply make it disappear. It makes an assumption that the information is unchanging or unimportant. As a result, we can't see it.